Lesson 1-5, converting mixed numbers and improper fractions. A mixed number, as the name implies, is simply something that has two parts. It's got a whole number part and it's got a fractional part. For example, 1.5. It's a mixed number because it's got the whole number part, the 1, and the fractional part, the half. In this lesson, we're going to go through the steps of converting mixed numbers into improper fractions, and then we'll do the reverse. We'll start with an improper fraction and convert it into a mixed number. Now, I should tell you that I have a little fun with the label improper fractions. Some mathematical mind gave it that label a long time ago. An improper fraction, in fact, I'll just use the example shown here in practice problem 1. 8/3 is considered an improper fraction because the numerator is greater than the denominator. The 8's greater than the 3. And I like to use my British nanny voice because to me, it seems like the word improper is a bit of an old-fashioned word. We don't hear that used as much in casual conversation in the year 2020 as maybe you would have in the year 1820, just guessing. And so I just think about this. I've got this image in my head of a British nanny scolding the fraction and saying, "Improper! 8/3, you are an improper fraction. 8 is much, much bigger than 3. Shame on you." There you go. The British nanny strikes again. Let's get back to math. Here, we've got the improper fraction shown with a visual model. Imagine that we've taken, in this case, 3 wholes, and we've split each of them up into thirds, 3 equal parts, and we've shaded in 8 of these boxes. So we've shaded in 8/3, 8 1/3. In the end, that gets us a model that shows 2 wholes, which are all the way shaded, and then we've got 2 1/3 that are shaded. 1, 2, 3, 4, 5, 6, 7, 8. That's how I get 8/3 altogether. Now, we can see from this visual model that, yes, I could think about each of these thirds on their own. That is true. And I can count them. And I can see and convince myself how there are, in fact, 8 of them that are shaded. But if I step back, I can also group them. And I can see with the visual model that, okay, well, this group makes a whole. This group also makes a whole, which is how I got whole number 2 here. And then I've got 1/3 and 1/3, or 2/3, left over on its own that does not make a whole. So 8/3 is equal to 2 2/3. If I were to, in this case, start with the mixed number, 2 2/3, and convert it into an improper fraction, here's what I would do. I'm going to keep the denominator the same. In this case, the denominator of the fraction was a 3. It's still going to remain a 3. Then I'm going to, in order to find the numerator, I'm going to take the denominator, 3, times it by the big whole number 2. 3 times 2 is 6. And then add what's on top. 3 times 2 is 6. 6 plus 2 is 8. 8 becomes my numerator. We'll practice this a few times. Let's look at number 2. This visual model is showing a whole divided up into 4 equal parts or fourths. I've got 1 whole completely shaded, and then I've got 1/4. Let's rewrite 1 1/4 as an improper fraction. I know I'm going to keep the denominator the same. 4 remains a 4. To figure out the numerator, I'm going to take my denominator, 4, multiply it by the big whole number 1, and then add the numerator, or add the 1 that's left over at the top. 4 times 1 is 4, plus the 1 on top is 5. And we can check this with the visual model. Does this make sense? 1/4, 1/4, 1/4, 1/4, 1/4, 5/4. Here's another way that, without the visual model, just showing unit fractions, how you could take this long set of adding 1/5 and show how, well, 5 1/5 make a whole, plus another 5 1/5 make a whole, plus 1/5 and 1/5 on their own are 2/5. 1 and 1 is 2. And then, of course, a 2/5 left over there. Let's do a similar grouping task down below. We're just grouping into wholes. A half plus a half, that's 1. Half plus a half, that's 1. Half and a half, 1. Half and a half, 1. And then we got a half left over at the end. Count them up, see how much our whole number is. 1, 2, 3, 4. Whole number is 4. And then the half left over at the end. And just for giggles, what would this be as an improper fraction? Well, we know the denominator 2 would stay at 2. We take the denominator, multiply it by 4. 2 times 4 is 8. Add what's on top. 8 and 1 is 9. And let's see if that checks out. Are there 9 halves? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are. Moving on. Here we have, again, I'm going to take my Sharpie and I'm going to cross out what the book has there. We're going to convert 2 3/8 to an improper fraction. British Nanny, we're coming for you. We know the denominator 8 is going to remain an 8. We're going to take the denominator 8, multiply it by the big whole number 2. 8 times 2 is 16. Add what's on top. 16 plus 3 is 19. Same steps over here. Number 6. 4 and 5, 6. We know the denominator remains the same. 6 stays a 6. We're going to take the denominator 6, multiply by the big whole number. 6 times 4 is 24. Plus the 5, 29. One and 4/5. The denominator stays a 5. Numerator, 5 times 1 gets us 5. Plus the 4 on top gets us 9. 3 and 1/4. Denominator stays a 4. 4 times 3 is 12. Plus the 1 on top, 13. There's my Sharpie. Seven thirds, denominator 3 remains a 3. Oh, let me pause. Here we're actually doing the steps in reverse. So, once again, I'm going to take my Sharpie and zip, zip. We know when we are converting this improper fraction into a mixed number, the denominator will remain the same. So I know I'm going to have a whole number here. I know I'm going to have a fractional part here. But I know the denominator of that fraction is going to stay the same. It's going to be a 3. So in other words, I can almost imagine that I've got question mark here, fraction bar, question mark here. But the thing I know is the denominator stays a 3 when I'm starting off. Now, let me explain how I solve for what the whole number is going to be, the big question mark. Here's how. I ask myself, how many times does 3 go into the 7 without going over? 3, 6, 9. Oop, 9's overshooting it. 3, 6. We could say that 3 goes into 7 twice, doesn't it? Because 3 times 2 is 6. 3 goes into 7 2 times without going over. And then for the tiny question mark, well, what's the leftover amount? Well, we already said that 3 goes into 7 twice. 3 times 2 is 6. Now the difference between 7 and 6 is what goes up here, the 1. It's the leftover part. Let's use that same strategy over here. I know my denominator for the fractional part is going to be a 5. Now let's figure out the big whole number. How many times does the 5 go into the 18 without going over? Skip count by 5s. 5, 10, 15, 20. 20 is overshooting it. 5, 10, 15. 3 times. 5 times 3 is 15. The difference between 18 and 15 is 3. Now you can always check by doing the reverse steps, which you've already been practicing. In other words, if I wanted to just check my answer by going backwards, I could say, well, 5 times 3 is 15. 15 plus 3 is 18. That checks out. Denominator checks out. Number 11. 6 goes into 11 one time without going over. 11 minus 6, the difference between 11 and 6 is 5. That's my numerator. And number 12, 7 halves. Denominator of the fraction stays at 2. 2 goes into 7 3 times without going over. 2 times 3 is 6. The difference between 7 and 6, or the leftover amount, is 1, 3.5.